Now here's an example of a test that shows one way of looking at a specific devices. Many devices today have regional IP blocking. So in this case here, the test was regional protection of an IPS on a firewall. We looked at a solution that wanted to test that could be set up to block traffic coming from different countries. So we set up a test that was looking at traffic generated from China IP addresses and Canadian IP addresses. And the policy of the device was to verify that the Canadian traffic got through what was monitored, and all traffic from the China IP addresses were blocked or tagged. And in the case of this test, from the tester solution, it would be nothing more than selecting what countries you want the traffic to come from, and this could be attack traffic or ordinary traffic or a combination thereof. And when looking at the device or the system that was actually being tested, it showcased very clearly that the Canadian traffic was let through but monitored, and that the traffic that we wanted to stop or block based on those IP addresses from China were blocked. So very simple tests can be set up in a couple of minutes, allowing you to test very specific capabilities of today's more modern IP filtering type devices and devices that are looking deeper and deeper into the type of traffic, not just if it's negative traffic. In addition, application-aware testing. And so we're talking about negative traffic, DDoS, malware, and a variety of other things. From the standpoint of testing scale and performance, having tools that will actually recreate in a realistic manner stateful and stateless application traffic from a variety of different applications. And in the case of CyberFlood, there's over 8,500 scenarios that can be tested on an ongoing basis on a continually updated database from an application data pool that covers gaming, business, web, video, voice, and even specific custom constructs to really test the behavior, application policies, what applications are seen, what policies you may be putting into place to allow, say, file transfer and not allow certain instant messaging or vice versa. You can really test and validate not only the security aspects of the application flows, but even the interworkings of them. So do certain policies do their job? Are you blocking certain types of traffic, letting through certain types of traffic, or giving specific quality of surface to specific traffic over other types? And on the other end of the equation, so we have normal traffic creation, which is application and attack, and other types of scale and performance testing. We have what's known as fuzzing. And fuzzing is basically iterative testing where you're taking a protocol, say HTTP, or any other protocol that might be available, and you're looking for unknown vulnerabilities of the target system. Are there open holes that otherwise would not be seen by the vendor or by yourself? And that could be utilized by a hacker or other entity that's trying to break through or trying to use that for some nefarious purpose. So with fuzzing, you basically look at a protocol, you look at a specific endpoint, and you target it with these automatic iterations. There could be millions of test cases. Once you hit the go button, basically it will cycle through up to 1 million or more specific test cases to find what holes might be in the devices that are ultimately being targeted. This allows you to deploy more robust applications, more robust services, and gives you the ability to monitor on an ongoing basis under new deployments what might be seen, what might not be seen from the perspective of protecting the network. And we employ a solution called Smart Mutation. And this basically gives you the ability to fuzz a testing protocol, say HTTP, with a nearly unlimited amount of specific vectors. And what that means is when you fire off the test, it's going to go through a series of different tests, each test case hitting a different aspect of that protocol or that service, and basically run until you tell it to stop, giving you the most coverage available in the industry. And you can even get down into granularity aspects of what aspects of the protocol you want to fuzz and repeat any test that finds a problem over and over again. So we give you the ability to go back, verify, and debug with very high accuracy, and do this under load. Again, we are overall looking at the aspect of testing any of our solutions under load, because that's going to be the ultimate condition of real services and real application live networks. So as far as security solutions will be the next topic here from Vlad. However, to wrap up on the CyberFlood solution, security performance and application performance testing, in today's environment, we're really looking at a variety of more powerful, more deep-ended solutions from next-generation firewalls, IDS, IPS, application layer gateways, and a variety of other deep hack and inspection engines that are really looking at more aspects of the traffic that's flowing through them. Not only are they protecting networks from nefarious traffic, they're actually monitoring and allowing normal traffic to be forwarded in the right manner, and being able to test that and understand where things are going to give you the best possibility for protection and where things are going to give you the best possibility for application access and assurance is a primary aspect of proactive security testing and proactive scale and performance testing. And with that, we'll pass it over to Vlad to go over Spirent Security Labs.
Hello, my name is Vlad Gostomowski. As you heard during the introduction, I run a team within Spirent. It is called Security Labs. You heard a little bit about some of our products, and now I'm here to tell you a little bit about some of the services which we provide. It's essentially security consulting focused on hardware and software testing, as well as device and protocol analysis. So some of our key areas is web and mobile application testing. That includes company websites, products, login interfaces, mobile applications that control devices, connect to control systems, automotive. If you've been paying attention to the news, you've likely heard that car hacking has been fairly big the past several years. We work with several car manufacturers, OEMs, and Tier 1 manufacturers to make sure that the vehicles and the systems that they put out are safe from some of the threats you may have heard about. It's not in the slide, but we also work with aviation companies to make sure that the plane systems and plane control systems are also secure. And we're trying to work more with drone manufacturers and UAV manufacturers to ensure that they cannot be hijacked or that the UAVs cannot be redirected from the aerial platforms. IoT vulnerabilities, we work with the Internet of Things, connected homes, home and building automation systems to make sure the devices that people put into their homes are secure and that the rightful owners are the only ones that are able to control them. Static code analysis means we go through the source code to make sure it doesn't have any vulnerabilities before the code is actually put on the device or put into the production. If you look at the most common vulnerabilities, buffer overflows, remote code execution, implementation of various algorithms, memory allocation, and of course, SCADA industrial control systems. These are the systems that make civilized life possible. They control everything from sewage pumps to refrigerators, nuclear power plants, essentially all industrial control systems, medical systems, heart pumps, that all falls within the category of SCADA and IoT. And we do work with a lot of medical devices as well. So talking a little bit about our team experience. We have several key areas within our team. We essentially have 4 towers. One is responsible for web application testing. We work closely with OWASP, which is the Open Web Application Security Project. We actually contribute a lot of information to the community, and we speak at OWASP conferences and participate in many open source projects. That falls in line with the web services testing, using SOAP API to talk to web applications and the web backend. Of course, there's the network testing team, which is what's typically considered network penetration testing or security testing services. And we have static code analysis, which I mentioned is not so much security testing, but review of the source code. And the other tower, of course, is the IoT and SCADA testing and embedded device testing. A lot of companies talk about doing security testing, and it's important to break down what it is they mean. A lot of organizations, when they mention security testing, what they mean is automated scanning. Now, that certainly has a place. However, automated scanning and automated testing misses quite a bit. So the approach that we take is manual penetration testing. That means an actual live person is sitting there and conducting the testing. They're analyzing everything that's sent to the application, to the device, and looking at the output and the results, and proceeding to the next step based on the results. When we do that with web applications, we use a man-in-the-middle proxy, And essentially every request that's sent to the web application is first reviewed by human. Server parameters may be changed or modified, and then the request is forwarded on to the web server. When we do network testing, we run certain manual scans, and we do incorporate automated testing as well to make sure we have fairly broad coverage. And depending on the type of testing, we go down to the packet level and perform fuzzing against certain devices and modify things at the packet level. With embedded device testing, we actually etch the chips and remove layers. We have a tunneling electron microscope that we can use to analyze chips. We connect to debug pins and identify JTAG ports and dump data from the chips in that way to gain access to the source code. Of course, automotive testing, where we work with vehicle components as well as entire vehicles to identify vulnerabilities that can be addressed before the vehicles are actually shipped to the general public. And SCADA systems, where we simulate the full environment of where the supervisory control and data acquisition system would be deployed. And we come out with the typical attack scenarios and typical threats that the system may face. And we simulate those threats, and we can do threat modeling with the organization we're working with to make sure it's an accurate threat model. And we work based on that. Another service we provide is managed automated testing. This is important for certain compliance standards, such as PCI compliance, as well as certain portions of the HIPAA standard. What that means is we conduct certain scanning and testing on the organization's behalf. We identify any false positives which may be within the results because it is an automated scan. We work with the client to make sure that the results are accurate and verify and validate as needed. We explain what the vulnerabilities are and what the best remediation is, and we work to assist to make sure that issues are remediated so the organization can stay in compliance. Another important note is network and wireless testing. And when we say wireless, we don't just mean Wi-Fi. Wireless does include Bluetooth. It includes Zigbee, Z-Wave, other things within the ISM 900 megahertz band. And it does include cellular communications. When we're working with cell phone manufacturers, that does mean standing up our own cell phone towers. Spire is actually one of the manufacturers of 5G cell phone towers. So we can stand up our own cell phone tower and emulate normal communication between an ISP or the phone company and the handset to conduct thorough testing and conduct security testing. Talking a little bit more about vehicle hacking. So a lot of the newer vehicles coming out are very connected. It's not just a radio connection that lets you play music. Cars have a lot of onboard diagnostic equipment. Some of the larger 18-wheeler trucks coming out have ability to actually update the engine firmware over the air when they pull into a truck stop. They have logistics planning. So it's actually possible to control the vehicle remotely over the uplink. It's possible to disable the vehicle over the uplink. And it's actually possible to put the vehicle in certain cases into a pre-crash condition over a wireless connection. So we conduct software compliance testing that meets a lot of the U.S. Department of Transportation standards. And we have some of them listed on the slide. There's actually additional ones. There's, I believe we cover 17 different DOT standards.